Let's apply Lipinski's Rule of 5 to aspirin to determine whether aspirin will be predicted to have good oral bioavailability based on Lipinski's criteria. Now, before we actually discuss aspirin, let's discuss what is the Rule of 5. So first of all, it's not a rule, it's more of guidelines because there are exceptions. But in general, it's used to predict whether or not a drug taken orally by mouth will be bioavailable. That means it goes into your stomach, into your small intestine, dissolves through the lipid bilayer of the intestinal wall, the epithelial cells, and enters into your bloodstream. This does not mean that it crosses the CNS barrier. So oral bioavailability with Lipinski's Rule 5 just means it enters your bloodstream. This does not apply to psychoactive drugs, although there is a modified Rule of 5 that does apply to psychoactive drugs. So this Rule of 5 basically predicts whether a drug will passively diffuse into your bloodstream when you take it orally. There are 4 criteria in the Rule of 5. The first criteria is that the molecule has a molecular weight less than 500 Daltons. Now, Dalton is used interchangeably with grams per mole, so this can also say 500 grams per mole. Now, let's evaluate how this applies to aspirin. The molecular weight of aspirin is 180.16 grams per mole. This is easily under 500 Daltons or 500 grams per mole. So aspirin passes the first rule, which is molecular weight. The second rule is that the logP, the logarithm of the partition coefficient, is less than 5. Now, what does this actually mean? The partition coefficient is basically just a value that compares how much of the compound dissolves in octanol versus in water at its equilibrium. So you have a bucket full of octanol and full of water, which don't mix. You add your drug in there, you wait for it to come to equilibrium. How much is in the octanol versus how much is in the water? So that's your P, your partition coefficient, and then you just take the logarithm of that. So the log being less than 5 follows the Lipinski's rule. A high log P, way above 5, means that the compound prefers being in a lipophilic environment, and a very low or even negative log P, much less than 5, means that the molecule would rather be in water. So in terms of bioavailability, this matters because you need to cross the intestinal epithelial cells, which have a lipid bilayer. So if your molecule has too low of a log P, meaning it's too hydrophilic, it will just stick around in the gut, and when it goes to the lipid bilayer, it will not be able to pass through. On the other hand, if log P is too high, it will enter the lipid bilayer and will get stuck there, and it will not want to go into the bloodstream. So if log P is in this special range of below 5, then we can say that the molecule will cross the bilayer and passively diffuse from the gut into the blood. The log P of aspirin is 1.2, which is below 5, so it will cross into the bloodstream. Now, of note, when you look up a log P value online, you might find something that says X log P or something similar. There's a lot of different calculated values that use software to determine the log P rather than experimental physical data, but you would just interpret it in the same way, being less than 5. The next rule is regarding hydrogen bond donors, and we want to have less than or equal to 5 of them. Now, a hydrogen bond donor is a nitrogen connected to a hydrogen, or an oxygen connected to a hydrogen. So if you see an NH bond or an OH bond, that will be a hydrogen bond donor. On aspirin, we can see that we have this carboxylic acid, and here we have an OH bond. This is a hydrogen bond donor, this OH. On other parts of the molecule, for example, we have an ester, we have a similar connection here, carbonyl bonded to an oxygen, similar connection to this one, but there's no hydrogen connected to this oxygen as there is here, so that's not going to be a hydrogen bond donor. So we only have one hydrogen bond donor, which is below 5. The fourth criterion is that we have less than or equal to 10 hydrogen bond acceptors. A hydrogen bond acceptor is defined in this case as any oxygen or nitrogen in the molecule that can accept a hydrogen from a hydrogen bond donor. So, for example, carbonyl, or the ester, or the carbonyl, or the oxygen here, these are all oxygens that can accept hydrogen bonds from a donor. So 1, 2, 3, 4, we have 4 hydrogen bond acceptors. So you just count the oxygens or nitrogens in the molecule. An important caveat is that if you have an oxygen or nitrogen that's positively charged already, then that does not count as an acceptor. So again, 1, 2, 3, 4, 4 hydrogen bond acceptors, less than 10, so it passes criterion 4. So in this case, aspirin passes all 4 of the Lipinski's criteria, and so based on that, we would predict that it has good oral bioavailability, because if a drug has only one violation of the 4 criterion, then Lipinski's rule predicts that it has good oral bioavailability. If it has more than one, it might have poor oral bioavailability.